welcome to this lecture on implicit functions. Now, until now we were differentiating functions where y could be expressed as x squared plus 2x plus 3, say, or y is equal to root of 2x squared plus 3, where y is in terms of x or y is a function of x. So we could express y all in terms of x's. That means x's were on one side, all the terms containing x were on one side, and y could be on the other side. These functions are called explicit functions. Okay, where y can be expressed exclusively or explicitly in terms of x. So now what is an implicit function? An implicit function is a function in which y cannot be expressed in terms of x. For instance, let's take this function x squared y plus y squared is equal to 5x. Now in this I am not able to shift all the y's on one side and all the x's on the other side. Such a function is called an implicit function. So today's lecture is about derivation of implicit functions. Okay, now in order to find out the derivative of implicit functions, we have basically two rules on how to solve such problems. So let's take rule number 1. Here we are going to find out the derivative of both sides using the chain rule. Okay, using the chain rule. Then gather all terms that have dy by dx on one side and solve for dy by dx. Let's see how to do this. Okay. Okay, this is rule number 1 for finding out the derivation of implicit functions. Now, step number 1 is find the derivative of each side using the chain rule. Let's take an example. Let's say y squared plus xy plus x squared is equal to 3x. So how will you find out the derivative of both the sides using the chain rule? So let's first of all find out the derivative of y squared. The derivative of y squared with respect to y is 2y. Now y is not a function of x, but y has to be, we have to find out the derivative of y squared with respect to y. So that is 2y. Now applying the chain rule, since we have to find out the derivative of y with respect to x, so we multiply it by dy by dx. Now let's take the center term. Now this is a product of two functions x and y. So this is a product of x and y. So as we know from the product rule, this is the first term, this is the second term. So the product rule says take the first term as it is, then find out the derivative of the second function. The derivative of the second function, that is y, is 1. And since this is y with respect to y, so we have to multiply it by dy by dx. Now, again the product rule says plus the derivative of the second function, that is y, into the derivative of the first function, that is 1. Okay. So we get here the second function is x dy by dx plus y. Now we know that the derivative of x squared is 2x and the derivative of 3x is 3. Okay. Now the the second one. Second step says gather all the terms having dy by dx. So we have here two terms having dy by dx. So we will have 2y plus x plus, and we'll take all the other terms on the other side. So this will be 3 minus 2x minus y. Now if we divide this expression by 2y by x, this and this will cancel off. So we will get dy by dx is equal to 3 minus 2x minus y upon 2y plus x. Okay, so this is the expression for dy by dx. So now let's take rule number 2 and solve the same problem using the second rule. So what does the second rule say? So the rule number 2 says, for implicit functions, dy by dx is equal to minus, okay, minus, find out the derivative of the expression or the equation taking y as constant. We'll see what you mean by taking y as a constant. And the second one is derivative of the equation taking x as constant. Okay, let's see how to do this. Let's take the same problem again and solve it using rule number 2. So y squared is equal to, y squared plus xy plus x squared is equal to 3x. This was the problem. So first of all, in this rule we have to bring all the expressions on one side. So the first step is to bring all the expressions on one side. So we will make the right hand side equal to 0. So we bring 3x on this side first, and then we apply the rule. So dy by dx is equal to, okay, we will take the minus sign as a minus sign. Okay, now first is derivative of this equation taking y as a constant. So when y is a constant, this becomes a constant. So we know that the derivative of a constant is 0. Now again, y is a constant. So constant, if it is this y, the value of y is as like it was 2, 3, 4, 5 or 6. So we keep y as it is and derive the expression that is x. So we know the derivative of x is 1. So it remains y. Now since there is no expression of y in this one, so derivative is equal to 2x, and the derivative of minus 3x is minus 3. So we have completed the numerator. Now let's take the same equation again, taking now x as a constant. So now if x is a constant, there is nothing here, so we just have to find out the derivative of y squared. There is no x term here, so we will say this is 2y here. Now x is a constant here, so x remains as it is. We are going to find out the derivative of y. So derivative of y is 1. Now x is a constant, so this becomes 0. This is a constant. Since x is a constant and this is a constant, so this expression is 0. Okay, so we get here y plus 2x minus 3 upon 2y plus x with the minus sign. Now since this is a minus sign and we don't want the minus sign, we just evaluate this expression using the minus sign. So this minus and minus, here is a minus, so this becomes plus 3. So this becomes 3 minus y minus 2x upon 2y plus x. If you see the previous rule, the derivation of this function using the rule 1, you'll find that this is the same answer we got for rule 1. Okay. Let's take some more examples on finding out the derivation of implicit functions. Okay, so let's take this expression xy squared minus x squared y is equal to 6 using rule number 1. Okay, using rule number 1, we say this is a product of two functions. So it will be x into differential of y squared. So differential of y squared is 2y dy by dx using the chain rule, plus the second expression, that is y squared into differential of x, that is 1. Now this will be minus. Since this is a minus, let's enclose this in a brackets and see what we get. So we'll be finding out the derivative of x squared y. So x squared, that is the first function, and the derivative of y, that is 1 into dy by dx, plus y as it is, and the derivative of the second function, first function, sorry, that is 2x, and the differential of 6 is 0. So this becomes 2xy dy by dx plus y squared minus x squared dy by dx minus 2xy is equal to 0. Now we gather all the terms of dy by dx. So this becomes dy by dx into 2xy minus x squared. Okay, and we take all the other terms on the other side. So this becomes 2xy minus y squared. Now we divide both the sides by this one, to get rid of this expression and get dy by dx. So dy by dx is 2xy minus y squared upon 2xy minus x squared. Okay, let's take one more example to make the rule very, very clear. Root of x plus y is equal to y squared minus 1. So we can write this as x plus y to the power half is equal to y squared minus 1. So let's find out the derivative of this one. So we all know that the derivative of this is a function, sort of a function of x to the power n. So how to find out the derivative? So this will be half into x plus y. Half minus 1 is minus half. Okay, multiplied by the derivative of the internal function. What is the derivative of the internal function? That is 1 plus derivative of y. Derivative of y is 1, and applying the chain rule, it is multiplied by dy by dx. So this is equal to, since this is y squared, so the derivative of y squared is 2y. Applying the chain rule, that is dy by dx. Multiply by dy by dx minus 0. Okay, now we can say that 1 plus dy by dx is equal to, let's take all the terms of dy by dx. So this is 1 plus dy by dx upon 2 root x plus y. We are taking this to the denominator, is equal to 2y dy by dx. Okay, so this will be 1 plus dy by dx is equal to, this 2 multiplied by 2 is 4, 4y root of x plus y into dy by dx. So let's take all the terms of dy by dx here in one place. So it is 4y root of x plus y, this is 1, dy by dx minus dy by dx is equal to 1. Okay, is equal to 1, and so we get here dy by dx into 4y root of x plus y minus 1 is equal to 1. So if we divide this expression by this one, we will get dy by dx. So dy by dx is equal to 1 upon 4y root of x plus y minus 1. Okay, that's the answer for this one. Okay, now let's take one example applying the rule number 2. So let's take an expression xy squared minus y is equal to x plus 4. Now it says that first of all you have to bring all the terms on one side. So let's bring all the terms on one side. This is minus x minus y is equal to 0. Okay. Now let's say how we get dy by dx. So dy by dx is equal to minus. So derivative of, in the numerator it is a derivative of the expression or the equation taking y as a constant. So taking y as a constant, so this will remain as a constant y squared, and the derivative of x is 1. So taking y as a constant, this becomes 0. Derivative of x is 1 and this is a 0. Okay, divided by derivative of the equation taking x as a constant. So since x is a constant here, so it is x and the derivative of y squared is 2y, right? And here it is y, so it is 1. So since it is x is a constant, so this becomes 0 and derivative of y is again 1. So we get here minus y squared minus 1 upon 2xy minus 2. Okay, so since we do not want the minus as it, so we can write like 1 minus y squared upon 2xy minus 2. Okay, this is how you solve the problem on implicit functions derivation using the rule number 2. So this is all for today's lecture. Until we meet in the next lecture to solve some more problems on implicit functions. Till then, thank you for watching.